Hello everyone, today I'm going to talk about searching algorithms. So the first one is going to talk about is linear search. Linear search is the most basic way of searching through a list. We iterate over all the elements in the list and check if any element will be equal to the target element. This is slow as it is O(n) time, since we need to go through all the elements in the list, and it is normally used for unsorted lists. So what's a better way than linear search? Well, for sorted lists, we would use binary search. Binary search searches in a sorted list, where it divides the array into halves to find a value by comparing it to a middle value. So the time complexity is O log n. Remember, the log here is in base 2. And let's see, the example here, we can say is find 6 in this array. So if it's linear search, we have to go from 1 and see if it's equal to 6, 3 if it's equal to 6, 4 equal to 6, and then 6. Oh yes, we find a number. That's really slow. But for binary search, we can half it and then we can compare the values. So you have 3 pointers. There's a low pointer, high pointer, and a mid pointer, where the mid would equal to the low plus high, and divided by 2. So we can see this index is 0 and this index is 5, and then so the index of the mid is 0 plus 5 divided by 2, and this is integer, so we round it down to 2, so 0, 1, 2, so the mid is here. And what we do now, we compare the mid number to our target value, which is 6, and we see that it is smaller. So what we do is we move the low pointer to the mid pointer, or we can make it to mid plus 1. It's the same thing. And then you calculate the mid again and repeat the process until mid is equal to the number, or that the high is smaller than the low. So that means that it is we don't have the number in the array. So here now I am going to write some code in Python. Okay, so this is in PyCharm, and we are writing a simple Python code to do the linear search and binary search. So you can see this. We have an array set up as the same example as before, with 1, 3, 4, 6, 8, 9, and it's stored in order, and it's the target value of 6 when you search. And this is a function where we're going to write the linear search. So linear search, basically we just iterate through all the elements in the list. So for example, we go for I in range length of the array, and then if array I equals target val, then we can just return I, and then if we don't find anything, we will just return -1. So this is how we write linear search. So let's test it out. We just go linear print linear search array and target val, and let's see. It was 3, so index of 3, so 0, 1, 2, 3, so 6. Okay, now let's do a binary search. This is the same thing, but firstly we need to have 3 pointers. So we have a low, which is equals to 0, a high, which equals to length array -1, and then we have a mid. You can just define it. It is low plus high divided by 2. So we have a while, low, if it's low smaller than equals to high. Let's just do that again. We actually put this in the while loop, and what then will we do is we compare. So if array mid equals to target val, then we will return mid. So and then else if array mid is bigger than the target val, then we need to make the high smaller, so equals to mid -1, or it can be equals to mid, doesn't really matter. And then else we'll do low equals to mid +1, and yes, so that's basically all. and if it doesn't find it, we just return -1. So let's try it out. So print binary search array and target val, and yeah, it outputs 3. So that's all.